Okay, so today we're going to be talking about plate tectonics. It's also called continental drift. There's a lot of evidence that came about with this. Um, the man's name was Hess, who realized that the lithosphere was made of several different plates and they made boundaries. The three boundaries we're going to be looking at are ridges, trenches, and transform faults. So, first, we're going to talk about divergent zones. Divergent zones happen because of convections. Remember the cold and the hot molecules moving around? They cause a drag on the lithosphere and it stretches. The lithosphere stretches. It doesn't actually, it's not fluid, it's not flowing, but it moves. The lithosphere crust weakens and there's faulting, there's breaking in the upper lithosphere. Sorry, I have a hard time saying that word. Magma starts to flow upward. New lithosphere crust is formed. The rocks are pulled apart over tension. Rocks under tension lengthen or break apart. Tension's the major type of stress at a divergent plate boundary. Divergent are also called spreading centers or rift zones. Some of these are examples of oceanic divergent plates. Do you notice what each one is called? That's right, ridges or rises. Mid-ocean ridges are divergent boundaries where convection currents in the mantle lift the ocean floor up and produce a rift in the lithosphere that follows the crest of the ridge. New lithosphere is created by volcanic activity along the crest of the ridge, and the plates on either side of the ridge are moving away from one another. The newest landmass on Earth are at the middle of a ridge. Convergent zones. Convergent plate boundaries is where two tectonic plates are moving towards each other, usually causing one plate to slide below the other. This is a process known as subduction. Generally, the most dense plate will go under the least dense plate. Remember, density causes it to go down. The collision of tectonic plates can result in earthquakes, volcanoes, formation of mountains, and lots of other geologic events. Compression squeezes the rocks together, causing the rocks either to fold or fracture. Compression is the most common stress at a convergent plate boundary. Earth's surface is made up of two types of lithospheric plates, continental and oceanic. The crust that makes up the continental plate is thicker yet less dense than the oceanic crust because of lighter rocks and minerals that compose it. Oceanic plates are made up of heavy basalt, the result of magma flows from mid-ocean ridges. When plates converge, they do so in one of three settings. Oceanic plates collide with each other, which is called an oceanic boundary. Oceanic plates collide with a continental plate, which is an oceanic continental boundary, or continental plates collide with each other, forming a continental boundary. Earthquakes are common at any time large slabs of earth come together with each other. A convergent boundary is no exception. In fact, most of the Earth's most powerful earthquakes have occurred at or near these boundaries. Ocean crust into ocean crust. It forms trenches and arc islands. When two oceanic plates collide, the denser plate sinks below the lighter plate and eventually forms dark, heavy basalted volcanic islands. The western half of the Pacific Ring is full of these volcanic island arcs, including the Aleutian, Japanese, Ryukyu, Philippine, Mariana, Solomon, and Tonga. The Caribbean and South Sandwich Island arcs are found in the Atlantic, where Indonesian archipelagos is a collection of volcanic arcs in the Indian Ocean. When oceanic plates are subducted, they often bend, resulting in the formation of trenches. These often run parallel to volcanic arcs and extend deep beneath the surrounding terrain. The deepest oceanic trench is the Mariana Trench, which is more than 35,000 feet below sea level. It is a result of the Pacific Plate moving beneath the Mariana Plate. This is a ring of fire, and it has several trenches. All of the purple are trenches. Okay, so oceanic crust into continental crust. They form trenches and mountain ranges. Trenches are usually in the ocean part, mountain ranges are on the land part. When oceanic and continental plates collide, the oceanic plate undergoes subduction, which means it goes under, and volcanic arcs arise on land. These volcanoes release lava with chemical traces of the continental crust that they rise through. The Cascade Mountains of the western North America and the Andes of the western South America feature such active volcanoes. So do Italy, Greece, and New Guinea. Oceanic plates are more dense than the continental plates, which means they have a higher subduction potential. They are constantly being pulled into the mantle, where they are melted and recycled into new magma. The oldest oceanic crusts are also the coldest, as they move away from heat sources such as divergent boundaries and hotspots. This makes them more dense and more likely to subduct. Right here, where the Nazca Plate and South American Plate come together, they form the Andes Mountains. Okay, continental crust into continental crust form mountain ranges. Continental convergent boundaries pit large slabs of crust against each other. This results in little subduction, as most of the rock is too light to be carried far down into the dense mantle. Instead, the continental crust at these boundaries gets folded, faulted, and thickened, forming great mountain chains of uplifted rock. Magna cannot penetrate this thick crust. Instead, it cools intrusively and forms granite. The Himalayas and the Tibetan Plateau, the result of 50 million years of collision between the Indian and Eurasian plates, are the most spectacular type of boundary. The jagged peaks of the Himalaya are the highest in the world, with Mount Everest reaching 29,029 feet, and more than 35 other mountains exceeding 25,000 feet. The Tibetan Plateau, which encompasses approximately 1,000 square miles of land north of the Himalayas, averages around 15,000 feet in elevation. And right here, this is where the Himalayas formed from the Indian Plate and the Eurasian Plate converging. Transform faults. When tectonic plates slip horizontally past one another, the lithosphere is neither created nor destroyed. Instead, blocks of crust are torn apart, broad zone of shearing. So shearing is the type of stress here between the two plates. Such boundaries are called transform plate boundaries because they connect other plate boundaries in various combinations, and they transform the site of the plate motion. The grinding action between the plates at the transform plate boundary results in shallow earthquakes, large lateral displacement of rock, and a broad zone of crustal deformation. When the forces are parallel but moving in opposite direction, the stress is called shear. Shear stress is the most common stress at transform plate boundaries. A good example of a transform fault boundary is the San Andreas Fault. Okay, hotspots. Hotspots are an area on Earth that exists over a mantle plume. The mantle plume is an area under the rocky outer layer of Earth called the crust, where magma is hotter than the surrounding magma. Heat from this extra hot magma causes melting and thinning of the rocky crust, which leads to widespread volcanic activity on the Earth's surface above the plume. While most volcanoes form along tectonic plate boundaries, mantle plumes and hot spots lead to their development as well. Hot spot volcanoes occur far from plate boundaries. I'm going to repeat that. You need this. Hot spot volcanoes occur far from plate boundaries. Because the hot spot is caused by mantle plumes that exist below the tectonic plates, as the plates move, the hot spot does not, and may create a chain of volcanoes on the Earth's surface. Neither the Hawaiian Islands nor the Yellowstone National Park are near plate boundaries. Rather, the volcanoes that form the Hawaiian Islands and the volcanic activity at Yellowstone National Park are due to locations over hotspots. The Aleutian Islands are the same. So, a chain of volcanoes, hotspot track, forms as the tectonic plates move over the plume of hot mantle material rising deep within the Earth. Some chains of volcanoes lie within the interiors of tectonic plates rather than along the edges. The volcanoes are progressively older away from the largest and most active volcano. So the largest and most active volcano is the youngest. These get progressively older. This one is a little older, this one is a whole lot older, and this one is the oldest. The hot spot is a large plume of hot mantle rising from the deep within the Earth. The line of volcanoes develops as plate moves over that hot spot, much like a line of melted wax forms as a sheet of wax paper is moved slowly over a burning candle.